Hi everyone. So in this session, we'll talk about how to design a patch antenna using ADS. Okay. So in this session, I'll talk about mainly how you will design a 3.5 gigahertz antenna that you can say as sub 6 gigahertz application, which means it can be used for sub 6 gigahertz application. Okay. So what you have to do, just open a Keysight ADS and then go to the new layout window. Okay, under that, name it as patch, suppose, or I'll write it better way in a patch antenna. Okay, and then just write 3.5. Okay, and I'll click on create layout. Okay, so this layout has been created now. Okay, and I can start designing the normal patch antenna. Okay, so as we know that we are using just a rectangular patch antenna, so for that, what you have to do, just go on this menu and click on insert rectangle. Okay, and draw a random rectangle. That is one that is mainly for the patch, and one I'll design for the feed line. Okay, generally. And now going for an exact dimension, what you have to do, just single click on that rectangle, come onto the right side under the property, you will see this width and height which is going. Okay, now you have to give this width as 37 millimeter. Okay, and height as your, you can say as 19.2, which is quite less, I guess. Okay, and this one. Okay, so I'll see, wait a minute. Okay, so this is my your patch. Okay, now again come back to this width and height to the second rectangle. Okay, so for that, what you will do, again click on that, go to the width. Now this is my 50 ohm feed width. I'm going to design a conventional 50 ohm feed line only, so there is no inset or that one. So this feed width only I'll going to use, that is 3.11. Okay, similarly the height will be normal around 6 mm suppose. Okay, since as it is not affecting the impedance, length will not affect. Okay, so I can give any length. Now what you have to do, you have to add these two elements, correct? That is my one patch and that is my feed line. Okay, so remember this, that this option on the snap mode, it is available, or you can say it is applicable. So you can activate and deactivate it but just by clicking once. Okay, so this is nothing but you selecting a midpoint. Okay, so what we'll do, we will select this option. Okay, which is saying as move using a reference point. So what we'll do, just click on this move using a reference point and zoom out, zoom in that, and as you can see it is automatically selecting the midpoint of this element. Okay, so I'll click once on that and it will select from the midpoint itself, and I will zoom out and I will go nearby to this patch antenna and zoom, and as soon as I'll move towards this patch, it will automatically select the midpoint of the patch, and I will leave this and I'll click escape. Okay, so what you can do, you have to unite these elements. For that, select this patch and then select this one. Okay, then go to the edit, go to merge and go to unite. Okay, so it is now united, and as you can see here, now this is only one outline. Okay, and that is one element. Now in order to simulate this antenna or this patch, first we have to define some property simulation settings, you can say. So go to the EM settings, EM simulation settings, click OK, and create EM setup view. Okay, and click OK. Now in this, okay, so as you can see here, before this port, after this port, one error is showing, means the port is still missing. So for that, go to this option, insert pin, and click on this and place that. So that is nothing but your port, that is P1. Okay, and again go to the EM, and this time you will see that these errors has been removed now. Okay, now first of all go to the substrate, and in this already actually I have designed a substrate having FR4 1.6 millimeter of height. Okay, so for that what you can do, just click on open as of now and click on this layer. Okay, so as you can see here 35 micron is used as a copper cladding. For the substrate it is used as FR4 already. Okay, for the substrate what you can do, just click on this and select this FR4 and thickness is 1.6 millimeter. Okay, like this you have to define the substrate layer. Okay, and click cross. So I'm going to use that same substrate only for this design. Okay, now what I can do, I just click on simulate for the simulation, and before that I'll set the frequency plan as well. So for the frequency plan, adaptive means for the complete range. So what I'll do, 2 to 5 gigahertz I'll start, 2 to 5 gigahertz, and one more I'll add, which is a single one, that is at 2, that is my 3.5 gigahertz. Okay, that we're going to use. So I'll rate it as number of points as 100. Okay, similarly under the output plan, click on all generated frequencies, save currents for all generated frequencies. Okay, like this you have to click on. Okay, and then click on simulate. Once it will be simulated, it will show the results. Okay, so as you can see here we are having one S11. So this is of no use, actually it is nothing but your phase delay. Okay, so this is your graph for the S11, that is your return loss in case of your patch antenna. Okay, so in that, if you want to edit, then what you can do, just click on that and you can increase the width till 4. Okay, and I'll click on OK. And if you want to place the marker, then go to this option and select insert a valley marker, means where the graph is at its lowest. Click on that and select any curve and place anywhere, and it will directly come onto the lowest one, that is 3.535 gigahertz. Under this minus 16 around of return loss we are getting. Okay, so I hope you got this point. Okay, and this is the overall design. So as you can see here, this simulation near about took the time of around 3 seconds. Okay, so I hope you got this design. Thank you.